Hello, for students, Mr. Lawrence here. We're going to do a little more with scientific notation today. We're going to use some applications. I'll do a couple sample problems. It won't take too long. And we're going to have to make sure we know what we're reading in the questions to be able to do these. So anyway, I went ahead and copied this off of, I think it's off of Wikipedia. We've got some populations of the different nations in the world. So it might be a little bit hard for you to read some of this. And you see I accidentally copied part of my recording device, but that's okay. It won't affect our data at all. And down here it says, in the table above, convert the populations of the following countries into scientific notation. Run your answers to nearest tenth. Oh, excuse me, nearest hundredth. So when I conveniently put the populations in here because I wanted you to be able to follow along, I'm hoping that you're going to pause the video here. I know some of you just sit there and watch and let me do all the work, and I'll let you know that you will not get the full benefit if you just sit and do it passively. You need to do it along with me. Anyway, so the population of Bangladesh, scientific notation. Right now I know the decimal point's here, and I need it to be there, right? And we're around to the nearest hundredth, so I'm going to be stopping right around that too. So I'm going to need something like 1 and 53 hundredths because I look here, right? 5 or more, I raise the score. So let's see how many times I'm going to divide this by 10. 1, 2, 3, 4, 5, 6, 7, 8. So I will multiply that decimal by 10 to the 8th power, and there is the population of Bangladesh in scientific notation. Oh, the population of Turkey in scientific notation. There's a decimal point. I need it to be here. Looks like my decimal will be 7 and 56 hundredths. And I'll multiply by 10, and I believe it's going to be to the 7th power. 2, 3, 6, 7. Yeah, okay. And South Korea, let's go in here. And so we'll call it 5 and 2 hundredths. And I believe that's the 7th power as well. And then finally, Afghanistan, 255 hundredths times 10 to the 7th. Okay, now we're going to eliminate this data here. Where is my shapes? I don't want you to see the data. Let's see, I can probably do it this way the easiest. There we go, and I like this. And then, haha, it looks like it's missing. It's not really missing, it's just hidden. And, oop, I missed the last one. Where'd it go? There we go. Okay, so now we're going to work with only the scientific notation numbers. So, question number 1 says about how many more people live in Bangladesh than in Afghanistan? Well, that sounds like a subtraction problem to me. How many more? So I'm going to take the 153 hundredths times 10 to the 10th, 10 to the 8th. And subtract the population of Afghanistan. It's going to be 2 and 55 hundredths. Now, some of you are going to be thinking that we're going to get a negative answer, but we're not. Just because the decimal is smaller for Bangladesh, it is not a smaller number because we're multiplying by a bigger power of 10. All right, well, I need to make a match, right? I need the 7 to turn into an 8, so I'm going to multiply by 10. And that means I'll divide by 10 here, and then this will move it over. So I'm going to have 153 hundredths times 10 to the 8th, and I'll subtract, always lining up my decimal points. Gonna need a 0 for a placeholder. And I'm ready to subtract. All right, so I'm gonna do a little borrowing. Get a 5 there, gotta borrow some more. All right, 12 minus 5 is 7, 2, and a 1. And my answer came out in scientific notation. And that should be correct. Yeah. Now, if I wanted to convert that back, of course, it would be a rounded answer. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Put my commas in. There you go, 127.5 million approximately, because we're dealing with rounded values. All right, next problem. If all the people in South Korea moved to Turkey and renamed the nation Turkorea, what would be the population? What would the population of Turkorea be? So I need South Korea's population. Okay, 502 times 10 to the 7th. And Turkey's 756, 10 to the 7th. I add them together. Well, let's see what I get. I don't have to adjust anything because my exponents are the same, so my answer will be 10 to the 7th. Then I'm going to have an 8, a 5, and a 12. I've made no mistakes in my mathematics, but this answer is not in scientific notation. I need the decimal point to move to here, which means I'm going to have to divide the number by 10. But that means I'll have to multiply this number by 10, and it'll end up being 1 and 258 tens, hundreds, thousands, 258 thousandths, right? If you wanted to round that to the nearest hundred, like the direction said, it would be 1.26. Okay, there we go. One more question. These are the kind of things you're going to be doing in class tomorrow. How many times greater is the population of Bangladesh than Afghanistan? Now, the key to this one is knowing that it's a division problem. Look, if you were 13 and I was 39, how many times older am I than you? Well, 39 divided by 13 gets you 3. So you see this is actually a division problem. With a simple example like that, sometimes we get fooled. So what are we comparing here? We're from Bangladesh and Afghanistan. Okay, so I've got 1.53 times 10 to the 8th, and I'm comparing Afghanistan, 200 like that, times 10 to the 7th. Okay. Now, it's kind of weird to see with these decimals, but when I went back up and I look at, say, this number here, minus all this stuff in my way, I've got about 152 million, excuse me. And for Afghanistan, I have about 25 million, about, I'm thinking it's going to be about 6 times bigger. That's what I'm thinking. But let's see what happens. Okay, first of all, I need to see how many times bigger this is than this. And after all the work we've been doing, that should be a simple thing. It should be about 10 times bigger. Oops. About 10 times larger. Okay. Now, this one here isn't so easy to see. I mean, I could guess because 1.5 isn't bigger than 2.5. Maybe I'll get rid of this idea and I'll start to apply it like this. Maybe I'll multiply that by 10 to turn it into 15. And then that, of course, would divide by 10 and cause it to be 10 to the 7th, right? And then I could compare these two numbers. And if I wanted to think of this one as maybe, well, let's see here, 2 times 7 would be 14. It's going to be 14. So I'm guessing it's going to be somewhere around 7 times bigger. Okay. 7's probably a little too much. It's probably 6 something. Well, let me go to a calculator. Let's see here. Sorry. Okay, so I'm going to go ahead and divide. And look at that, I got 6 on the nose, didn't I? And remember when I looked at the original numbers, I got 6 on the nose. So it's going to be about 6 times bigger. Let's do one more example of that, which would be a little bit easier. Let's say I had this number here. Um, 12 times 10 to the ninth. And this number here, 4 times, 4.1 times 10 to the, let's make it 7th. Now, again, I'm only estimating. I'm going to wonder how many times bigger the number on the left is from the number on the right. Well, that's about 3 times there, right? But over here, 10 to the ninth divided by 10 to the 7th is about 10 squared, or 100. And so what I'm trying to get at is that if the decimal part of the number is 3 times bigger, and the base exponent part of the number is 100 times bigger, well then it must be 300 times larger. Yeah, so I found out the decimal part, divided it, got the base part divided, and multiplied the answers together. That's all I'm trying to say. Okay, we'll get some practice with this, and tomorrow I know you might be just a little bit confused. Don't worry, I'll straighten it out for you. All right, Mr. Lawrence signing off. Good night, everybody.